here for our wrecking ball lab. You can make your own wrecking ball. I used my dog's Kong, right, his little toy, put a string through it, and that made a good wrecking ball for me, so thank you for letting me borrow that. You could also, if you don't have something that already has a hole in it, you could use a bag and put an object inside of that bag and tie it to a string, and you could make your wrecking ball of that. Things that you can use for string would be jump ropes. If you have a swing set or something outside, you can tie it from that. So making your wrecking ball is completely up to you with what you make it out of. The second part to that is you want an object that you are going to hit with your wrecking ball. The object, you don't want it to be too heavy. You want it to actually be able to be moved by the wrecking ball, but you don't want it so light that it flies really far when you hit it. So I have a pretty lightweight wooden brick that I'm going to use. I have a piece of tape here so I can just remember where I'm going to set it after each round when I lift my wrecking ball up. I've chosen the four different heights to lift my wrecking ball up in centimeters: 10 centimeters, 20 centimeters, 30 centimeters, and 40 centimeters. I'm going to pull it back to that height, release it, and I'm going to measure how far the brick moves forward. And for this beaker, I'm going to ask you to sit on our couch. Alrighty, so trial 1, 10 centimeters. I've done all 3 trials for each of my distances. 40 centimeters for this particular setup was about straight across, right at that 90-degree angle. To calculate my averages, as a reminder to you, I would want to add together my 3 trials and divide by the number of trials. So since I had 3 trials, I'm going to add, for 10 centimeters, I would add 12 plus 10 plus 9, press our equal sign, divide, press 3, and our equal sign, and that will give us our average. If you were going to turn this table into a graph, you want to make sure that you're graphing just your averages. We're going to use a bar graph. My y-axis title is going to be distance traveled by the block because that's what our averages represent. Okay, my x-axis title is going to be the height of the pendulum, so how high I pulled up the pendulum. And my labels, which are going to go on my x-axis, would be 10 centimeters, 20, 30, and 40, and I would then graph the averages. Okay? So I went ahead and I calculated my averages. I created a graph so I could see any sort of patterns or trends that might be developing in the data that we collected, right? So what we can see here is it appears that as the height of the pendulum was increasing, the distance traveled by the block also increases. Well, why did that happen? And that's what we're going to figure out. So remember that potential energy is the stored energy in an object. Potential energy is then transformed into kinetic energy, and that kinetic energy can be transferred to another object. So as the pendulum got higher in the air, it stored more potential energy, which means it was able to convert or transform into more kinetic energy. The more kinetic energy that pendulum had when it got to the bottom of its swing means the more kinetic energy it was able to transfer to the block. So if it's transferring more kinetic energy to the block is going to be able to move further. Now, the block itself also has potential energy when it's sitting there before it gets hit by the pendulum. Once it gets hit by the pendulum, it takes the kinetic energy that just got transferred from the pendulum to the block, and it's going to move forward. While it's moving forward, it is building its kinetic energy as well, right? Both objects in this system have potential and kinetic energy. And where does the potential energy come from that the pendulum has? Gravity, because it's gravitational potential energy. So the pendulum gets its energy from gravity. Where does the block get its energy from? The pendulum. So the more energy that the pendulum has, the more energy that the block will have. And If the pendulum is able to transfer more kinetic energy, we're going to see more motion from the block.